Hi, my name is Leandro Facchinetti, and in this video I want to talk about a project of mine. It has recently been released. It's called Caxa, and its purpose is to package Node.js applications into binaries. In this video, I'm going to talk about exactly what that means and why you would want to have that. I'll also do a demo showing how Caxa works in action, and then I'll briefly explain how Caxa works. I will not go in depth because there will be another video with a code review in which I go over the entirety of the code base and explain in much more detail what's going on. So this is just going to be a high-level overview. And then finally, to close the video, I am going to compare Caxa to existing Node.js tools for packaging. And I'm going to try to convince you that Caxa may be the best for your use case. Anyway, so let's jump right in and talk about why you would want to, and this is Caxa, by the way, why you would want to compile Node.js applications into binaries and what exactly that even means. Well, it means that you're going to take your Node.js application, any kind of application. It may be a web server, it may be a command line tool, it may be something else entirely. And Caxa is going to compile that into a binary, an executable. So on Windows, that would be a .exe file. On Linux, it will be just a binary that you can run on the command line or that you can double click on some file manager. And in macOS, it will also be one of those binaries, but it can also be a .app. So it's as simple as downloading something, clicking on it, and it will run as if it was a regular app, because it will be. So that's what Caxa does. Why would you want to do this? Well, it depends. In some cases, it is to make deployment easier. Instead of having to manage Node in a server and install stuff using npm, never mind all that. You can just compile into a binary, ship the binary, and just as long as the binary is in the machine, you run it, it will be fine. And it's also a good idea to package applications if you're going to distribute the application to your users in some other way, like a command line tool. You can tell people to install using some package manager and whatnot, but you can also just go to your project's page, click on this download button, and run it. And that's the entirety of the story, which is a good story for distributing binaries. And of course, that combines with other strategies, like you could upload to Amazon S3 or upload this to any kind of CDN. Anyway, it will be just a single file that people can run and it will just work. And people don't have to know that it's in Node.js. They don't have to understand NPM. They don't have to care about it all. They will just download something and it will work. So that's why you would want to package. And that's why I created this project in the first place, because I had an application that I wanted people to be able to try without much effort. So I created Caxa to be able to compile this into a binary that I ship to my users, and I also ship to my servers. It just runs the application. It's fine. Okay, so that's why you would want to compile your Node.js applications into binaries. Now let's look at how that works. So I have here in front of me a simple web application. It's written in TypeScript and it looks like this. So it's a simple to-do app. You can say like, hello, Caxa, and you can delete items from the list. It's a simple to-do app. The purpose of this app is just to show how you can package it using Caxa. Currently, it's not packaged. It's not packaged at all. I'm running this on the command line using ts node dev, which is something you can use to reload the server when the files change. In any case, so I'm going to stop the server now. This was running in localhost, so now this will no longer be running, and when I refresh the page, it's no longer working. Now let's install Caxa and set it up to use. And they use the simple use case here for Caxa. The way you can use Caxa is so simple, and that's one of the advantages of using Caxa. So all you have to do is install Caxa, and you probably want to install this as a development dependency. You probably don't want this to be when in the packaged binary itself, right? So you install Caxa as a development dependency, And then to use caxa, you say caxa, and then I'm going to go for the help here because I don't remember all the commands off the top of my head. So here are some examples. I will want to compile this. I'm on Mac OS, but this works on Windows, Mac OS, Linux, and soon it will also work in Raspberry Pis. I'm working on that. So I want a binary in Mac OS that I can just run from the command line, and then later I will also show a .app because it's kind of fun. So I'll just follow the example here. So npx caxa, and then the directory that I want to package is the current directory because I am on the project that I want to package. Then the command that I want to run, well, that is going to be node. I want to run node on my compiled TypeScript. So yeah, I guess that's something that I need to do first before I even do this. So let's save this for later. And before I package my app, I need to prepare it. So if I wrote this in Java in TypeScript, I need to compile it to JavaScript. If I am using some sort of bundler like Webpack to produce my front end, so suppose you have fonts and images and JavaScript for the front end that you want to pre-process and bundle in some way, or you want to minify CSS, whatever you need to do to get the app ready for distribution, that's what you need to do. And here I already have it compiled, but I'm going to delete the directory to show you how it would be done. So in most cases, these kinds of things that you would need to do to prepare the app for distribution are in the prepare script, but that's just by default if you have this in a prepare script when you run npm install the package or when you run npm publish, whatever the case may be, when you are installing or bundling the package, it will run the prepare script for you. And that's advantageous because you don't have to remember to take one extra step when you are maybe writing some continuous integration scripts to package and distribute your application. You can just say npm install and it will run the prepare script for you. So I guess that's what I'm going to do right now. I already have the Node modules installed, but I'm just going to run npm install, which is going to run the prepare script, which runs tsc to compile my TypeScript into JavaScript. And here is my JavaScript. Again, this is totally configurable. Do whatever you need to do. Call Webpack, call NCC, call parcel and rollup and grunt, gulp. It doesn't really matter. As long as the app is now ready for distribution, all the dependencies are installed, everything is compiled, and you could just publish this to NPM and people that have Node.js and NPM could just download, for instance. You don't have to publish to NPM if you don't want to, but it's just a matter of getting the app ready for distribution, if you know what I mean. Anyway, so now that this is done, we can come back to our command we were writing. So npx caxa, the directory that I want to package, and then the command. So in the command, you have to remember that when you're packaging the application, now you are running the application from within the package. So you need to be aware of this when you write the command that you would like to run. So again, I'm going to just save this for a moment. And how would I run this application if I was not packaging it? Well, now that everything is compiled to JavaScript, I would just say node lib. By default, it will look at the index.js file, and it will start my server. So again, I can come back here to localhost 5000, and there it is. So one other interesting aspect of this application that I forgot to mention is that it's using native modules. So it's using one of those extensions that was written in C or C++, and that has been compiled into a file that is specific to my platform. So it's not a JavaScript file, it's not a TypeScript file, it is a .node file that is specific to macOS. In fact, I think I can find under Node modules and grab for something that ends in .node, and there it is. So I am using SQLite for the server for the database in my simple application, and this is depending on a package called Better SQLite 3, which is a native module. This is important because there are many packaging solutions in Node that don't work with native modules. Caxa works with native modules. It works on every platform. If you can run your app like this on the command line and it works, then I guarantee you it's going to work with Caxa. No surprises. And that's one of the fundamental tenets of how I build Caxa. It's meant to just work with your application. You don't have to specify which files to include in the package. You don't have to specify if you're using native modules or not. No handstanding. It will just work. Okay, let's continue. So we had this much. And I said that you need to be aware that you are in the package when you're running this. So now I have to put some prefixes here on this thing. So for instance, lib. Well, there is this magical prefix, caxa, that is your packaged application. So if I am able to run this with lib on my command line, then I should say caxa lib when I'm calling it. And then caxa, when actually running this in the package, caxa will replace this placeholder with the path to the actual application that you are running. So that is the placeholder that is substituted with the actual place where your application will be running. And this will be an absolute path to the file that we want to run, so to the directory that contains index.js. And that means that you can have any kind of command. Here I have node lib, but you could have anything at all. This command that you need to run your application is completely arbitrary. You can do whatever you want. If you need to maybe burn into the package some command line arguments like, I don't know, some path to something like an argument, whatever. If you need to burn that argument into the call so that every time someone runs your app, they will have this command line argument passed into your application, it's fine. Caxa is completely agnostic with respect to what you need to do to run the application. Okay, and now let's go to the final bit of magic, because Caxa is not only packaging your application, it's also packaging Node.js itself, the executable for Node.js, within your package so that your users don't have to know about Node.js, know about NPM, know that it's written in JavaScript at all. They don't have to know. It's just a command line tool. It's just something that they click and it works. So I have here the other piece of magic, and that is I am putting in your Node modules bin. So in this directory, you can see executables for all the packages I installed. So for instance, I installed the HTML entities package, and it has a command line executable. Well, it's living in this node modules bin directory. When I say things like npx caxa, it's going to look into node modules bin and it's going to look for caxa. So that's the executable that is running. Well, same is true of Node.js itself in the caxa. When caxa is packaging your application, it's putting the Node.js executable in node modules bin. So what you can say is node modules bin caxa. Now keep in mind that I am running, not caxa, Node, right? So I am running now the Node.js version that was packaged along with my application. So this is just this command here that we had to run this application. But in theory, if your application needed some other command to run, that would be fine. So for instance, you could, if you wanted, not compile to JavaScript, but use TS Node itself. So here we were running the application using TS Node dev. If you wanted to, you could include TypeScript in not the development dependencies, because currently TypeScript is a development dependency, but if it was a production dependency here in this section instead, then you could deploy the application with the TypeScript compiler with the TS Node dev, and then here on the command line, instead of saying node, I would have to say TS Node dev. Whatever the case may be, Node is here, of course, it needs to be, because TS Node is going to call Node at the end of the day. So TS Node, I guess if you're running a GitHub app it needs to start with a different command line executable. Jest is another example. So maybe if you wanted to have an executable that runs tests, then Jest is something that is special. You don't call Node, you call Jest. Again, any kind of executable, if you have it in your Node modules bin, it will be there. Node will be there as well because caxa will put it there. And then finally, here in our example, we have to say what the output is. So I'm going to call this caxa example. So that's going to be the name of my executable at the end. Of course, the name caxa here is arbitrary. It's not arbitrary in these cases. These are placeholders for where your application will be packaged. But this is an arbitrary name. It could be anything. Anyway, with that out of the way, let's run this and you will see how fast it is to compile an application using caxa compared to other things like that exist in the Node ecosystem that require you to compile Node.js from scratch. Caxa is super fast. And it is even faster after we run it the second or third time. But it's definitely not compiling Node.js from scratch. In fact, it's already done. But it's not compiling Node.js from scratch. It's just taking the Node.js executable that is currently running caxa and it puts it in the caxa, in the package. Anyway, so with that, we now have a new file here. It's called caxa example, and we can run this because it's a binary. And it is going to start the server the same way that it did on the command line before. So now I can go to the server again. And this caxa example is just a binary that I can take anywhere. And it doesn't rely on my application at all. So just to prove my point, I'll go to the temporary directory and I will run the caxa example from there. And as you can see, it is running just fine. And yeah, Node modules that are native working just fine. The SQL connection is there. It's connected. And the source code for this example application will be available to you because it is, in fact, one of the examples here in the caxa repository, the link to which will be below. Anyway, so here is the application, and you can go read the source and convince yourself that it's actually going to the database to store the items that are here. But trust me, it's going to the database. It's using SQLite, so it is using a native module. So there you go. That's how you use caxa to package your application. Okay, that was all fine and good. I had an executable, but an executable may not be super friendly depending on the kind of application that you have. So as a gimmick, I also have another way to build the caxa, which is not a single file, but a .app file for Mac. And of course, this is Mac specific. On Linux, you will have to produce regular binaries. On Windows, you will have to produce regular binaries that are .exe files. But on Mac, you have two options. You can also produce .app files if you want. So again, let's build on the same command we had before. And this is it. But now the output will not be caxa example. It will be caxa. Caxa is always lowercase, example.app. When you say .app at the end, then caxa will know that you want to build a .app. So now caxa is building the .app for us, and it's going to show up on Finder. You can just put this file anywhere, and it will show up as an app file that you can double click in Finder. And here it is, caxa example. You can just run this, and it will pop up a command line that is showing you everything that's going on in your app, like server started at port 5000. So you can go to the browser and you can see that. So I think that's probably the easiest way to distribute an application for people to try out on their own machines. So you can think of an app that needs to be self-hosted and you want people to be able to try the app on their own machines easily. Distributing a .app is probably the easiest you can do for macOS. In fact, doing exactly that was one of the motivations for building caxa in the first place. Now, this is great, but I think it's worth pointing out how caxa works. because there must be some magic here, right? How do you compile this binary that works with any kind of project and that compiles so fast and whatnot? So the root of the problem with packaging Node.js applications is native modules, because they have to be loaded from the file system. While you can play all sorts of tricks with require or import to change the way that JavaScript is imported from other JavaScript files, you can override import and require and do whatever else you need to do when you're packaging an application. The native modules break. The native modules need to be files in the file system. And then what some applications that try to package Node.js apps do is they copy the .node files, the ones we looked at before. I showed you how there was a .node file in my Node modules directory. So what some of these solutions for packaging Node.js applications do is they take the .node files and they put it somewhere in the file system, and then they require from that place. So they put the .node files in a temporary directory for you. Well, what caxa does is just take this idea to the next level, to the ultimate consequence. What if we put the whole application in a temporary directory and run it from there? So the caxa binary, the one we are looking at, so this caxa example binary that we are looking at, what is the caxa example binary? Well, I can open it with Visual Studio Code, and at first it complains because it's a binary file, but I want to open it anyway. So this is a binary file, and yeah, you can see that it's very much a binary file, but it has a placeholder right here. So this preamble is a binary that looks at its own source code and finds your application. So what I did here to build this binary is I looked at the directory that you wanted to package. I created a tarball out of the directory, so I effectively compressed the directory into a single file. I appended this file as a binary here to this executable. And then I also put at the end some instructions as JSON. So this is a simple instruction as JSON. And it tells you the identifier for this exact build. So I took the name from the directory, so caxa example. No, not from the directory, from the output that I wanted to have. So I wanted to produce a binary that read caxa example. So that's where this name comes from, caxa example. And then there is a unique identifier that is always different. Every time you build your app, it will receive a different string. And then the command that you wanted to run, and that is just the arguments you passed on the command line, including the placeholder and everything. So that's the structure of a file. It is something called a self-extracting executable. What this means is that when you run this executable, so we were looking at this executable, when you run this, it will look at the placeholder that was somewhere, so this placeholder here, that separates the sections of the file. So this, before the placeholder, is a program that I wrote that looks at its own source code, not source code at this point, it looks at its own executable as a file. So it reads itself, finds the tarball, extracts the tarball to a temporary directory, and runs whatever you told it to run on the JSON at the end. So we can in fact inspect what this temporary directory looks like. Here in the caxa documentation, there is a section on where are the packages uncompressed at runtime. So where do the packages end up when running them? Well, they end up at this location, which is the temporary directory for your operating system. And then there is a directory called caxa, created by caxa in there. So here is our caxa example with that unique identifier for the build. And here is the whole app. You can see that it's the whole app, including the node modules, including the bin directory, including node as an executable in there. and then all the other executables like caxa itself, it's also there. So this is how caxa packages your application. It just creates a tarball of your application, puts that tarball into an executable that knows how to extract itself, and then it appends some instructions on how to actually run the application. And then this strategy works in any operating system, macOS, Windows, and Linux. And it works with any kind of application, including native dependencies and whatever other shenanigans happen in your application. You can include images and assets and fonts, and you can bundle your Webpack thing into the application. It will just distribute that. It will be fine. It will zip, or more accurately, it will tarball the whole directory anyway. And in fact, just to show how this works, let's come back here to the caxa example directory, or actually, rather, I need to go now to the caxa source code itself. So this is a clone of the repository over here. And what's going to happen is I'm going to look at how to build, just to drive the point home of how these binaries are built. There is no magic. So let's look at this directory and understand everything that is in here. So there is the caxa itself is written in TypeScript for the most part. So here is the source, and I will go over everything that's going on in this file. There is no real big magic going on here. It's a rather small file. But the main app is written in TypeScript. But then there are these stubs. The stubs are written in Go. I needed to bootstrap the process with a language that is compiled into a binary. And this Go stub, its job is to do the thing I talked about before. It's going to look at itself as a file, find that division, that caxa placeholder that separates the binary from the tarball of your application. It's also going to look at the footer for the command that you want to run, and it's going to untar into a temporary directory and run the application. So I have these stubs compiled already, and they are distributed with caxa, so you don't need to have Go installed to use caxa. You do need to have Go installed if you want to develop on caxa and contribute to caxa. Anyway, so now let's build a binary that is going to use these stubs by hand. Just understand everything that's going on. So I'm going to copy the stubs that are for macOS. There is one for each operating system. Soon there will be one for Linux, ARM, for Raspberry Pis as well. We'll get to that. But anyway, so here I have the stub. I'm going to copy it to the temporary directory, and I'm going to call it caxa by hand, because that's what we're doing. So now let's go to the temporary directory, and we have caxa by hand. Now I need to tarball something and put it in the executable. So I'm going to maybe create a file. Yeah, I will create a file. Hello. So now I have a file called world.txt, and its contents are hello. And now I need to tarball this. So I'm going to tar create zip file that is going to be going to the standard output. And I'm going to tar world.txt, and I'm going to append the result to caxa by hand. So now that's interesting, right? Did you know that you can take an executable file in any of the three major operating systems that have different executable formats, but you can append any kind of data and it's still a valid executable? Did you know that? I didn't. Until I tried to develop caxa, I didn't know that. But yeah, you can just append any data to an executable and it remains valid and executes just fine. The loader for applications just ignores whatever data it doesn't recognize. That is true of portable executables on Windows. I'll try that again. Portable executables on Windows. It's true of Mac-O. I don't know how to say that, but it's spelled like this. This is the format for executables in macOS, and it's also true of ELF, the format for Linux. So that is something that you can do. You can just append to any executable. In fact, if you look at the source, or not the source, the produced binary for a stub, you can see that it ends with that placeholder. So that's now appending the tarball at the end, and we will use this placeholder, this binary here that is the result of compiling this Go program. We'll look at its own source, looking for that placeholder at the end of the file that is now in the middle of the file because I appended, right? So this star command appended some stuff at the end of the caxa by hand. So now I will print some stuff to the end of the file. This is going to be the footer, and it needs to start with a new line. And now I need to pass it some JSON that will be first the identifier, and then the command to run, which will be a list with different parts. So now the identifier, I can pass whatever string I want here. If you want to use this stub to generate self-extracting executables, you can do that. You don't have to use caxa, you can just use the stubs. Anyway, caxa by hand, that's going to be my identifier, and I'll just pass some string here that is going to be unique to identify this build. And then what command do I want to run? Well, I want to run a command that will cat. So here I don't have to specify caxa in the beginning because cat is not in the caxa. It is in the I am supposing that your client, whoever is running this, will have cat installed, which is true because I'm running on macOS, so cat is available. And then I need to cat something in the caxa. And what is in the caxa? Well, it was called world.txt. And then we can run caxa by hand. But before we do, let's also open that temporary directory we looked at before. So I happen to have closed it. Okay, I opened it again. So we have here that directory that is the temporary directory, lives in my temporary folders. This is where caxa is going to extract and uncompress my world file when I run caxa by hand. Oops, I forgot a comma right here. So I'm going to restart the process and see you on the other side of this edit. And we are back. And here you can see the comma that was missing. Now we can run caxa by hand. And look at that. It produced the caxa by hand directory with the identifier that we put there. And it extracted the hello file, the rolled file that contains the string hello. And I just moved that around. Okay, so it contains the string hello. It ran the command that I told it to run that cats that file and produced hello on the output. Excellent. So that is exactly how caxa works. For more detail, again, subscribe to this channel. I will post another video with a full detailed explanation of everything that goes in the code to make this work. Okay, now let's end this video by comparing caxa to the other tools in this same space in the Node.js ecosystem. There are other tools to package your application into binaries. Here are the most popular, and we'll look at how they work and how caxa compares to them. So to begin with, the most popular by a far margin is package, or PKG. And the way that package works is it takes your application and it traverses the files in your application, looking for the files that are required somewhere. And it finds this tree of files. It compiles the files using V8, the engine for running JavaScript that is under the hood in Node.js. It takes the snapshot of the compiled bytecode. At this point, it's a machine bytecode, a virtual machine bytecode, and it embeds that into a modified version, a patched version of Node.js. That's how it works. Now, what are the advantages and disadvantages here? The advantage of package when compared to caxa is that it's hiding the source code because it's pre-compiling it into bytecode. And there are other things that may be advantageous using caxa as well, but I think that's the one that stands out to me. Now, what are the advantages of using caxa? Well, the first is it works with any kind of application. There has been recently a development in PKG that tried to patch the problems with native dependencies, doing exactly the self-extracting trick of putting the not node file somewhere in the file system. So it works like that. And I think it works in most cases. It has not worked for me using Sharp library in Node.js that has native extensions. So Sharp in Windows did not work for me using that new support for native extensions in package, but it may work for you. I don't know. But caxa is guaranteed to work with anything because it's a strategy that is as simple as extracting stuff into a temporary directory and running Node. That is going to work with every version of Node forever, which is not the case for package, because package needs to patch the binary to work. It needs to patch Node.js itself to load things differently, to load that snapshot of the virtual machine, and even to load your other files like your assets, like your images, your JavaScript that are run on the client side. All those, the CSS, all those files need to be stored somewhere. They are stored in a virtual file system. They call it the snapshot file system. So Node.js itself needs to be patched to load those files differently from the snapshot file system. That is not the case with caxa. Caxa is going to uncompress the files into a temporary directory into your actual file system. So there is no patching necessary. And package needs dispatches, and they are running behind, actually, I think, for half a year now, with Node.js versions that have been released and have not been patched for package yet. No shade on them. I know that open source is hard. It takes a lot of time. And people behind package, they are the Versal company. They have other priorities, so more power to them. But it also means that package is, the maintainers exist, they are there, they're responding, but it's not super actively developed anymore. Anyway, so that is package, a great thing. It was the first one I learned about, and I used it for a while before I ran into the issues that made me build caxa. Package is great. It's the most popular one, but it has these problems that caxa fixes. Oh, another thing I should mention is the binary size. I mean, binary sizes in Node.js are ridiculous because you have to embed Node.js itself into the executable. So if you have a simple command line app, it will be like 30 megabytes, which is awful if you think about it, because compared to things like Go, it will be 2 megabytes, or if you compare it to C, it will be a couple hundred kilobytes. But I think it's worth, because writing JavaScript is fun and you can do web apps very easily, and there are all the other advantages of using Node.js. So the binary sizes are kind of ridiculous when compared to other programming languages, but when compared to other packaging solutions, caxa is very good because it's by nature compressing the files. And of course, you could compress files when distributing them, but caxa is already doing that in the binary itself. So the binaries are smaller. And of course, they will uncompress somewhere, so there is no way around that. The uncompressed versions in the temporary directory, they will be bigger. There is no way around that. But yeah, the binary sizes in caxa are rather small, while in most of these other tools, they are kind of large. They are larger, at least. So a simple Hello World app in caxa, it's around 30 megabytes, and in package, it's around 80, if you care about that. And you could always just compress the output of package if that's what you need. Next up is Nexi. It's similar to package in structure. It has some of the problems fixed. So Nexi has more up-to-date versions of Node available, but it still suffers from some of the same problems, and it doesn't even attempt to solve the problem of native binaries, the native modules. There are some explorations on solutions that follow the same self-extracting archive solution that caxa uses, in this case just extracting the .node files, but still using the same strategy. There are some solutions, but they are not there. On the other hand, Nexi has some nice things that caxa doesn't do, like I comes for the .app, but that's something that I'm probably going to work in the near future anyway, if people care about this. So next, there are tools like Boxed Node. These tools work differently. They don't try to compile your JavaScript into a snapshot. What they do is recompile Node.js itself, embedding your application as if your application was part of the Node standard library. If you don't know about this, the Node standard library in part is written in JavaScript, and when compiled, the JavaScript is turned into something that goes in the Node binary. So what Boxed Node does is it recompiles Node.js, pretending that your application is part of the standard library, so it becomes this one thing, this giant binary that has your application in it. It works great with native modules, it works great with any kind of app, but you do have to bundle your application into a single file before running Boxed Node. And that's because it only runs with a single file, a single JavaScript file at a time. That's no big issue. You can just use a bundler like Webpack or NCC. But it's kind of annoying. And I don't know the story for including images, CSS, and so on in your application. I don't know how that would work. But the biggest drawback here is that it compiles Node.js from scratch, from the source. That takes hours. On my machine, it took hours, at least the first time. Then when you compile again, it's relatively faster. It's like 5 minutes, but nothing compared to the speed you saw here in caxa, because caxa is just effectively compressing a directory and appending some files. But Boxed Node is super slow to compile. There are some things that are advantageous about using Boxed Node. As far as I can tell, the binaries produced by caxa as it stands are not signable. So if you need to sign the executable for distribution, that's not something that caxa can do, I think. I don't know much about signing. I'll learn more about this in the future if people ask for it. But people from the Boxed Node project say that the binaries that they produce can be signed. So there you have it. Then there is JS to bin that should follow a strategy similar to Boxed Node, but I tried to use JS to bin. It just didn't work. It produced binaries that didn't work at all. I have no idea what happened. So I went to the next one. Enclose is the predecessor of package. It seems to have been abandoned in favor of package. I think it's by the same authors. It was closed source. It was paid. I did not pay for it. I didn't even try it. I think it has been abandoned. And then there is nar. Nar has also been abandoned, I think, in favor of package. At least that's what they recommend in the README. But nar is super interesting. And nar is the inception of caxa. Not that I developed nar, I wasn't involved at all, but I was trying out all these tools, trying to find something that satisfied my needs. And then I found nar, and it hasn't been updated in 4 years. I paid it very little attention, but when I tried it, it worked. It worked with every Node version. It worked with native modules. What was nar doing? Well, it was using the idea of a self-extracting archive. And there are many things that nar didn't do that caxa does. So that's why I couldn't just use nar. But it follows the same strategy of a self-extracting archive. And that's why it worked, even though it has not been updated in 4 years. And I was intrigued. Well, what is the strategy here? How can this work without having been updated while other tools have all these other issues? Well, nar is short for Node Archive, and it's exactly what you think. It's just a tarball of your application. But the way it bundles your application is not with these stubs written in Go that we talked about before, not here. In the Node, in the caxa application that I showed you, there are these stubs. And this is original work. The stubs being written in Go, and the way I append the payload to the end of the executables, that is our original work. In nar, the executable is not using a Go executable as the stub. It's using a shell script as the stub. So that only works in macOS and Linux. It may also work in Windows using the Windows subsystem for Linux, but I haven't tried it. And I don't want people to have to install Windows subsystem for Linux to be able to use my packages. So it made more sense for me to use this stubs written in Go. And if you go and peruse Google, NPM, and whatnot, you're going to find many other packages in this space. None of them are well documented and maintained and work well and polished in the way that caxa is. So that's how caxa compares. I think it's the best solution for packaging Node.js apps, as long as you don't mind sharing the source, because the source is going to be plain in the package, in the caxa. You can always try to obfuscate the JavaScript as part of your build process. So my build process here in my example was simply to compile TypeScript, but you could do some kind of obfuscation. But as long as you don't need that, if you really just want to share your application, it may be an open source application or it may be closed source, but your clients could have the source and you don't care about that, then I think that caxa is probably the best solution out there, because it will just work with minimal configuration. You just really have to tell it what to package, what to run when you are running the executable, and what you want the executable to be named. It will produce executable files for Windows, Mac, and Linux. Raspberry Pi coming soon. Caxa is the work of many hours of research. If you come here to the repository, you will see that there is a full documentation of everything I learned along the way. There is still a lot more to talk about. When I go over the source code, we'll see that there is a lot more intricacy to the project, though it's rather small. It's like around 200 lines of code. It's a fairly sophisticated idea. It's kind of a hack too, and it's a lot of fun, but it has been the work of many hours. If you want to support this kind of work, make sure you subscribe to this channel and use caxa, and also contribute on Patreon, on PayPal. If you want to do a recurring thing, I have a Patreon. If you want to do a one-time contribution, you can go to PayPal. And it's thanks to the support of all my patrons and all my other people who are contributing that I can afford to do this kind of thing, putting in so many hours, and also I had to buy a PC to make sure that everything worked on Windows as well, and it does. Windows is fully supported. And yeah, so if you care about this kind of work, then make sure you subscribe to the channel and contribute. And thanks for watching. I hope you have fun packaging your applications with caxa. Make sure you let me know what the kinds of things that you are building with caxa. And thanks for watching this one. I see you on the next. Watch out for that other video with the code review. I see you around. Thanks for watching. Bye.